812, which is titled Multiple Representations of Exponential Functions, and we're going to answer the question that says, what is the connection? So question 821 says, look at some of the connections between the multiple representations of an exponential function. Part A, Arnold dropped a ball during the bouncing ball activity and recorded its height in a table. Kind of like what we did way back when. Part of his table is shown at the right. They want to know what was the rebound ratio of his ball. So from the numbers that they gave us, we're going to take the 67.6 and we're going to divide it by the 84.5. If you do that on your calculator and then hit the equal sign, it's going to give you a rebound ratio of 0.8. And then to work your way backwards and fill in these two numbers, you simply take the 84.5 and divide by 0.8. It'll give you 105.6. And then you take that number and divide by 0.8, and it'll give you 132. So 132 centimeters is where that ball was dropped from. And then, how many of you remember what happened when you dropped the ball? Each bounce did what? Decreased, okay? So they wanted to know what was the height that the ball was originally dropped from, roughly or approximately 132 centimeters. And then today we're going to learn how to write an equation that's going to represent this data that we have right here. And the way you do that is you're going to say that y is equal to the starting value. So you have to always, either they're going to give you the starting value or you have to work backwards to get that starting value. And then you're going to take the ratio. So in this case, we found the ratio to be 0.8. And then you're going to take it to the power of whatever number is in this column. So in this chart, it represents the number of bounces. So how many ever bounces would be the exponent. Now, when you're calculating this, and you need to follow order of operations, what do you do first? Do you multiply first, or do you do the exponent first?
Exponent.
You always want to do the exponent before you multiply. Okay? Question B says, a major technology company, Expo Grow, is growing incredibly fast. The latest prospectus, which is a report on the company, says that so far the number of employees Y could be modeled with the equation Y equals 3 times 4 to the power of X, where X represents the number of years since the company was founded. Okay? So based on this equation, what was the starting number? 3. And then what is the growth rate? Is the 4. Okay? So question Roman numeral 1 says, how many people founded the companies? They had 3 founders. That was their starting. Okay? Question Roman numeral 2 says, how can the growth of this company be described? So it's going to multiply by 4. That base right there. You can also say it quadruples, but it's going to multiply by 4. So part C says a computer virus is affecting the technology center in such a way that each day a certain portion of the virus-free computers is infected. The number of virus-free computers is recorded in the table at right. So the first thing they want to know is how many computers are in the technology center to begin with. 27, right? That's day 0. There's 27 of them, okay? Roman numeral 2, what portion of the virus-free computers is infected each day? We got 1/3. How did we get that? If you take 18 over 27, bless you, it's going to reduce to 1/3. What is this, a factor of 18 and 27? Bless you. 9. Okay. Which would reduce it to 2/3, but 1/3 is the portion that is getting infected. Okay? Roman numeral 3. How many computers will remain virus-free at the end of the 3rd day? So here's what you need to do. You need to take the 12 that's here and multiply it by the 1/3, which is the same as dividing by 3, which means that 4 would be infected. But that doesn't mean that there's 4 that's virus-free. That means you have to take the 4 and subtract it from the 12. Okay, same thing that we did here. If this is 2/3, 2/3 from 1 whole is 1/3. So that's why 1/3 is the answer here, not 2/3. Okay? So you're going to go 12 minus 4. That means there would be 8 computers that will remain virus-free at the end of the day. Okay? Part D says, as part of a major scandal, it was discovered that several statements in the Expo Grow prospectus were false. If the company actually had 5 founders and doubles in size each year, what equation should have been reported in the report? Yes. And then what's the base of the x? 2. Oh, that should be x. So it should be a starting number of 5, and then since it's doubling, you're going to put a 2 right there. So the starting is 5, and then the doubling is right there. Okay? All right, top of page 6. If you're still writing, you'll see that in just a second. There we go. Question 822 says, most of the exponential equations you have used in this course have been in the form y equals ab to the x. Explore using the student tool. You can do that in just a minute. But first they want to know, what does the a represent in this equation and what does the b represent in this equation? So we've already talked about it a little bit. The a is going to be the y-intercept, where we start, or you could say the starting value. Okay? And then b is going to be the multiplier, what happens from day to day, or month to month, or year to year, depending on, or bounce to bounce, okay? Depending on what the situation is, okay? So for part B, it says, how can you identify A by looking at a table? And how can you find it in a situation? Give an example for each representation. So on your table, you're going to fill in some numbers of what's going to happen and make up a situation. It could be growth or it could be decay. Okay? And your 0 is going to be when you have your A. That's what we call your starting value. Okay? And then over here or down here, you're going to write what your situation is. Do you want to do the bouncing ball? Do you want to do bunny rabbits that are increasing? Okay? But the 0 is going to be your starting. Okay? And you're going to make up your own situation. I'm not even giving you one because I want you to do it on your own. Okay? Part C says, how can you determine the B in each representation? And then you're going to use arrows or colors to add your ideas about B to the examples created in Part B. It's going to be your multiplier. And then the last question for today is, what connections are you sure you can make in an exponential function web? For example, if you have an exponential equation such as y equals 20 times 3 to the power of x, can you complete a table? If so, draw an arrow from the equation to the table. It's already there. Okay? As shown at right. Draw arrows for any other connections you have used so far. And then you're going to fill in these blanks. I feel confident in blank. Do you feel confident in writing the equation? Do you feel confident in making a table? Do you feel confident in drawing a graph? If you drew all your graphs yesterday and they looked great and you did a good job, then say you're confident in that. But I need time exploring or getting help with blank. Okay, what part do you think you could use some help with? All right, when you're done filling that in,